Hello and welcome back. For the following problem, we're going to identify the different types of intermolecular forces for the following three cases. The very first thing that you always want to do when approaching the different types of, identifying the different types of intermolecular forces that you can have is you always want to make sure you identify whether your molecule is polar or nonpolar. So in the case of hydrogen bromide, this is a polar molecule, as we previously stated in the previous problem. So since it's a polar molecule, we know we're going to have our dipole-dipole interaction, and we're going to have London dispersion. Remember, London dispersion is always present. Well, since we've done that one, let's go on ahead to the next one. In this case, well, we have to first identify whether or not this molecule is polar. In this case, we have two highly electronegative atoms, so we have an uneven distribution of electrons, thus giving us a polar molecule. Well, since we have a polar molecule, we know this is going to be dipole-dipole, and we're going to have London dispersion. We also know we don't have any hydrogen bonding because hydrogen bonding only occurs when in the presence of nitrogen, oxygen, and fluorine when hydrogen is bonded to one of those atoms. Finally, in the last case, let's do hydrogen peroxide. Hydrogen peroxide is right here. Well, is this molecule polar or nonpolar? Well, if you said polar, then you are right. Remember, each of these oxygens are going to have a bent molecular geometry, thus having an uneven distribution of those electrons. So this is a polar molecule. So we're going to have our dipole-dipole. We're going to have a London dispersion. And we have an oxygen-hydrogen bond. Thus, we have hydrogen bonding. Hopefully, you're able to follow me with identifying the different types of intermolecular forces that are present in these three molecules. Thank you.